forgot to press record until now, but whatever, we'll keep going. Okay, so we've noticed that in our booklet, we had the blue, 2 markings and 90-degree angle, which is a perpendicular bisector. We noticed the angle markings making an angle bisector. Can you guys find these markings right here? Just 2 tick marks, no 90 degrees. Yes, very good. The 2 tick mark word is the median. Okay, last one. We're looking for something that only has a 90-degree angle, no tick marks at all. What is that one called? Just 90 degrees, no tick marks. The altitude. Okay, these words were the words we learned in Unit 6, but it's been a minute, so we have to remember them and remember the important things about them, and it's all about these markings. I'm going to rewrite these letters for you for a second because it will help you remember some things in a little bit. So if we write down the letters, this was a perpendicular bisector, this was a angle bisector, this was a median, this was an altitude. It spells out PAMA when you spell it like that, PAMA. Now, all of these special segments had points of concurrency that was also vocabulary in that booklet. So if we go back to the perpendicular bisector page, what was its point of concurrency called? So look at the page next to perpendicular bisector. There's a title at the top. What did it say? No, sorry, the top title, that big old word on the next page. Look to the next page, Brian. Yep, that word. Circumcenter. So the point of concurrency for the perpendicular bisectors is called the circumcenter. Okay, let's do the same thing, but for our angle bisector, what is the name of its point of concurrency? In-center. What about median? I like that you said middle for median because yes, it does hit that line segment in the middle, but its point of concurrency is called the centroid. And then the point of concurrency for all of my altitudes is called it is something with an O, orthocenter. So if we put the initials of all of these words, we had PAMA from the special segments, and we have SECO from the points of concurrency. That's going to be really helpful for you to maybe remember what goes with what. So PAMA, SECO reminds me that perpendicular bisectors go with circumcenter. The angle bisectors go with in-center. The medians go with the centroid, and the altitudes go with the orthocenter. PAMA, SECO. That's going to be your little acronym to maybe help you remember these things. Now let's talk details of these points of concurrency. For the circumcenter, some things to realize about this is that it is equidistant from the vertices of the triangle, which means that all of these little segments that are dashed, so I'm going to zoom in on this so I can highlight more accurately. All of these little dashed segments are going to be equidistant. That means they're congruent, which means the equations are equal to each other. For the in-center is going to be equidistant to the sides of the triangle. So our little dashed lines here go from the in-center straight to the sides. Those are all going to be congruent. So if we were setting up an equation, we'd make them equal to each other. The centroid is also called the center of gravity, so this is a really important one if you're ever trying to build something. You have to check out the centroid of your triangle, make sure the center of gravity is supported. But the center of gravity, or the centroid, is located 2/3 of the distance from the vertex to the opposite side. So if this segment right here was 2, this segment right here would be 1. So the long side would be double the short side. But what's more important for me, because that relationship is important. Bye, Kate. Have a good time on your field trip. The centroid has a formula that we're going to use to find the centroid. That formula is x1 plus x2 plus x3, all divided by 3. Oh, there's the phone. Hold on. Okay, so we did x1 plus x2 plus x3 divided by 3 creates your x coordinate for the centroid, which follows that y1 plus y2 plus y3, all of the y's of these coordinates you're given of the vertices, if you divide them by 3, you will get the coordinate point of this centroid, this little middle piece right there. So this formula you will use today. This formula you will need to know. It's the average of the x's divided by the average of the, or comma, the average of the y's. Okay, the orthocenter, if we just look at the orthocenter for a second, it is where all of the altitudes meet. What's kind of funky about the orthocenter is that it can be inside or outside of the triangle, and sometimes it looks really wild when it's outside. Just know that the orthocenter is where all of the altitudes connect. Now, let's go through some always, sometimes, or nevers. This is a little bit extra, so all of the stuff up at the top with Pamasico, that's what I really need you to know. But let's talk about some of these sometimes, always, or nevers. A perpendicular bisector blanks passes through a vertex. That sometimes happens, meaning that it would go right into the center of one of the angles and also be an angle bisector, which is wild. A median always intersects the side of a triangle at its midpoint, because that's its definition. An altitude is sometimes in the exterior of the triangle. An in-center is always on the inside, so in-center, inside. A circumcenter sometimes lies on the side of a triangle. And a centroid is never going to be outside of a triangle because the centroid should be inside of it because it's the center of gravity. So if you get a coordinate point for your centroid that is outside of your triangle, you're wrong. Again, the main thing I need you to know here, I know I just kind of zoomed past that. Let me go back. Sorry. Some of y'all were still writing. I need us to know Pamasico. If you can remember what goes with what, that the perpendicular bisectors are your circumcenters, that's going to be super helpful for you today. Now, the back of this document, okay, I'm going to leave this up for a while, but I'll talk about the back of the document. The back of the document is your level 0 today with your group. You all picked who you're sitting with. So your team needs to finish the back of this document, which is just identifying the different special segments. When I come by and check it, I will say, yes, you're good to go, and you will go to a whiteboard and start working through 10 levels. How many levels today? 10 levels that will review you through Unit 6 and Unit 8 so that we're prepared for our test that we're taking next class. Those of you who have missed some classes in between, today's going to be super helpful for you as long as you are a sponge and you listen to your team working through these problems. If you can do the problems on the levels, you'll be fine on the test. So, you and your team, which you picked where you sat today, Samaya, you can pick where you sit. You and your team are going to work through this back document together. When your team is finished, you call me over. I either say yes or no, and you'll move to level 1. You are identifying what I gave you, perpendicular bisector, angle bisector, median, altitude, and then you're identifying the point of concurrency down here. You can't just do it by yourself. You are working with a group, so your whole group has to have the same answers. While we're working, I'll leave the other slide up on the TV so you can look at it. You don't have to flip back and forth on your paper. But we're ready to go. We're going to review all day today.